Hi guys, good day everyone. So we're still on gas law, we have many of them. So we've talked about Boy's law and we've learned something from it. Also from the little thing we did, found out that we've learned something from Boy's law. So now today we'll be talking about Charles' law. Now Charles' law states that the volume of a given mass of gas is directly proportional to its temperature at constant pressure. Let me write that down. Now, okay, this is what Charles law states. And remember, when I talked about how you understand gas laws, now when you see what it states, try to see what the meaning. Now they say Charles law states that the volume of a given mass of gas is directly proportional to its temperature, provided the pressure is constant. This is provided the pressure is constant. So now from this now, how do we understand it? Now calm down, breathe very well, then think. Now, the volume of a given mass of gas, meaning V, is what? Directly proportional. Now, remember what I told you. Now, when you say inversely, it is 1 over whatever your right is. If you say inversely to 1, it is 1 over 1. So now we say, when we talk about Boyle's law, the volume was inversely proportional to what? The pressure. So it was 1 over pressure. But now, it is not inversely, it is directly proportional. So now as it happens to be direct, we have what? V directly proportional to what? The temperature. Now provided that our constant here is what? Pressure. Now remember in Boyle's law, our constant was what? It was the temperature, but now in Charles' law, our constant is the pressure, sorry. Now just know you're not supposed to cram this in, you're supposed to understand it. So when you are ever called to explain it, you're ever called to state it, you'll be able to state it without even thinking too much. Now when you see what is written here, as you go read more on it and try to derive the formula, that's one way to understand Charles' law or any law at all. After you state the law, try your best to derive the formula. Okay, so now let's try to derive the formula of Charles' law. Now remember, states that the volume of a given mass of gas is what? Directly proportional to its temperature, provided the pressure is constant. So we have what? Pressure as our constant, P. So now we have V equals to TP. Now what do I do now? Always when this is our constant, we can also put this as K. Now we always have to make our constant stand alone. So to make the constant stand alone, what do? You divide through by T. Remember, simple words, calculations. To make one stand alone, you have to divide with the other one. If two things are this way, one is this one. You want this other one here to stand on its own, you divide it by the other one. So now we have T and our constant, and we have volume on its own. So now we also want temperature, the constant to stand alone. So first off, we divide through by T. So you divide by T, divide by T. What will happen here? T would cancel T. So our constant is equals to what? V all over T, which gives us our formula. So now our formula for Charles' law is now what? V1 all over T1 equals to V2 all over T2. Now you say we got just V all over T. So why is it V1 all over T1, V2 all over T2? Now remember, we're always talking about what? An increase in this leads to what? A decrease in this. So an increase in this leads to an increase in this. And now this one is what? Directly proportional. So an increase in volume would lead to an increase in the temperature. So as V1 is increasing, T1 is increasing, and as V2 is increasing, T2 is increasing. Now this is the formula. Now let's try to solve questions with our formula. Let me draft out a question that we'll try to solve together. Now this is our question. We said at 17 degrees Celsius, a sample of hydrogen gas occupies 125 centimeter cube, which is the volume. So what will be the volume at 100 degrees Celsius if the pressure remains constant? Now this is the degree, this one, and this is Celsius. Now we have what we call temperature. And our temperature has a particular digit, which is always in Kelvin. That's how we always put temperature, in Kelvin. So whenever you're given a question and then you see the temperature in Celsius, you have to change to Kelvin. And to change to Kelvin, you add 273. But if you're asked to change from Kelvin to Celsius, you minus 273. So every 0 degree Celsius is equals to 273 Kelvin. Kelvin does not have degrees, just Kelvin. So now we first of all change our temperature to from Celsius to Kelvin. So let's do that. Okay, so now I'm bringing out the data. Now we've changed the first temperature, and we say at this temperature it occupies a volume of 125 centimeter cube. This is hydrogen gas. H2 is hydrogen gas. So it occupies 125 centimeter cube. So our V1 is what? 125 centimeter cube. So what will be the volume at T2? So if T2 is 100, now you add what? 273 to make it Kelvin, which would give us 373 Kelvin. Then what will be V2? So V2 is unknown. We are looking for this man. So now remember our formula. Our law states that what the volume of a given mass of gas is what directly proportional to its temperature provided pressure is constant. So our formula we derive from the law we state. These are formulas, so we're just going to write our formula out again. So we have V1 all over T1 equals to V2 all over T2. Now you can solve this way. So first off, you cross multiply. Now why I always do this with the letters before imputing the values is because it is more understandable, and also you'll not be confused doing it this way. So you cross multiply, you have V1 T2 equals V2 T1. Now to make V2 stand alone, what do we do? Just the same way we derived that formula. To make A stand alone, we divided. So now to make V2 stand alone, we do what? We also divide. Now you divide by what is close to V2, which is what? T1. Divide through by T1, divide through by T1. T1 will cancel T1. We are left with V2 equals V1 T2 all over T1. Now you can input your values. You say input values. Now we have V2 equals V1. Our V1 is 125 times T2, which is what? 373 Kelvin, divided by T1, 290. And this would give us, you use your calculator, you'd have 161. And remember, don't forget, it is in what? Centimeter cube, because we're looking for volume. Okay, so the next video I'll be doing, I'll bring out the questions where to try again by ourselves. Don't forget to like, don't forget to subscribe, and hit the notification button so whenever I make any video, you know about it first. Thank you.